So students, moving towards our next topic, that is the industrial applications of the Lee-Chattelier principle. We will take two examples, that is the Haber process. In the Haber process, there is the formation of ammonia, and in the contact process, there is the formation of sulfuric acid. So both these reactions involve the reversible reaction. So we will apply the Lee-Chattelier principle on these reactions to increase the yield of the products for these reactions. So what is the Haber's process? Haber's process is a process in which hydrogen gas reacts with nitrogen gas to form ammonia, right? So what are the reaction conditions for this process? The reaction conditions that are maintained for this process are that the temperature is maintained at 400 degrees Celsius, pressure is maintained at 200 atmospheric pressure, and iron is used as a catalyst. When these conditions are applied, the yield of ammonia increases from 33% to 98%. Now you may see here that the yield has increased to an appreciable extent. That is from 33 to 98%. How does that yield increase? It increased by applying these reaction conditions. So how do we know that what kind of reaction conditions should be provided in a reversible reaction to increase that yield? We select the reaction conditions based on the effect of the change in conditions on the reversible reaction. We have discussed the effect of change in the reaction conditions in the Lee-Chatelier's principle topic. So we will be just applying those change in conditions in order to increase the yield of the product. Now moving towards the effect of change in temperature for this process, we have an equation in which nitrogen and hydrogen reacts to form ammonia, and this reaction is accompanied by the release of the heat energy. So this means that this is an exothermic reaction. So if we want the reaction to proceed in the forward direction, what would we do? This is a reversible step, and the forward reaction is exothermic. So this means reverse reaction would be endothermic. So what should be done in a chemical system so to allow this reversible reaction to proceed in forward direction favorably? What would we do? We would decrease the temperature. When we would decrease the temperature, the chemical system would oppose by increasing the temperature. So how would it increase the temperature? It will favor the exothermic reaction. And which reaction is exothermic? That is the forward reaction. And what is happening in the forward reaction? There is the formation of ammonia. So since our product is ammonia, our desired product is ammonia, and we want more ammonia, so we want to bring those changes in the reaction mixture that would result in the production of more ammonia. So what is expected that we would decrease the temperature of the chemical system so to increase the concentration of the ammonia. Now this effect of change in the temperature may be applied to this chemical system, but unfortunately we cannot apply this effect to a larger extent because of certain reasons. First reason is that you must have read that the rate of any kind of reaction is directly proportional to temperature. Why? Because when the temperature is increased, the energy of molecules in the reaction mixture is increased. So when the energy is increased, the molecules would collide together. There would be more effective collisions between the reactant molecules, and more effective collisions means that more product will be formed. If we are decreasing the temperature, then the number of effective collisions will decrease. Right? Effective collisions mean that the collision in which the reactant molecule when collide produce the products. So when the temperature is decreased, the number of effective collision also decreases. So this is not favorable for us, because when we will decrease the temperature to increase the formation of ammonia, then that reaction would proceed at a longer time span. For example, it would take 2 days, it may take 2 days. So this is not favorable for us. So we don't apply the effect of change in temperature on this chemical system. So therefore the temperature is maintained at 450 degrees centigrade. So in order to get the sufficient yield of ammonia, a compromised temperature is kept at 400 to 450 degrees centigrade. Why a compromised temperature? Because we cannot afford the lower temperature because of the slow speed of reaction. So in order to compensate that at increased temperature, we will apply another change in the condition on this equilibrium system. And what that change would be? That change would be of the pressure. Now you may see here that there are 4 number of molecules on the reactant side and 2 number of molecules on the product side. So in which side the pressure is less? On the reactant side there is more pressure. On the product side there is lower pressure. Greater the number of gaseous molecule, greater will be the pressure. Lesser the number of gaseous molecule, lesser will be the pressure. So we will apply the effect of pressure. Now just see that what do we want? We want more production of ammonia. So in order to get more ammonia, what would we do? We would try to introduce that chemical change, we would try to introduce that change in the condition which would result in the formation of more ammonia. For example, if we increase the pressure, then how the chemical system would respond? Chemical system would try to oppose that change by decreasing pressure. So now observe that in which side the pressure is decreasing, forward or the reverse side? It is the forward side, because in the forward reaction there is the less production of number of molecules. So if we increase the pressure, the reversible reaction would move in the forward direction. So what is happening in the forward direction? There is the formation of ammonia. So by increasing the pressure, we are favoring the formation of more ammonia. Now see that when the pressure is applied, the reaction would proceed in the forward direction and more ammonia would be formed. So this is the process of this is a summary of Haber's process. In Haber process, a low temperature increases the yield of ammonia, but it is too slow. A high temperature improves the rate of reaction but decreases the yield too much. So we just maintained the compromised temperature of 450 degrees C. Secondly, a high pressure increases the yield of ammonia but costs a lot of money. So the compromised pressure is achieved, that is 200 atmospheric pressure. In addition to these changes, iron catalyst is also added within the reaction mixture. What would this iron catalyst do? This iron catalyst would results in the increase of the rate of forward and reverse reaction, and because of the increase in the rate of forward and reverse reaction, there would be an earlier establishment of the dynamic equilibrium. So the amount of the ammonia that is produced will be achieved earlier than the expected. So this was how the Le Chatelier principle was applied in the Haber's process.